Let's say that this chair represents an atom of carbon. Carbon is unique from all other elements because it has its own building block, or its own atom. Carbon atoms are unique from atoms of other elements. An atom of gold would look different. An atom of nitrogen would look different. However, any two atoms of carbon are identical. That is to say, all atoms of carbon are identical, just like all atoms of gold would be the same, or all atoms of nitrogen would be the same. The building blocks or atoms of any individual element would be exactly the same. It all depends on how you were to arrange the atoms. The arrangement of the atoms would affect how it looks. The form that we see carbon in depends on how the atoms are arranged. But carbon atoms can have special features that allow them to arrange in a variety of forms. Coal is just one of the many forms carbon can take on. Carbon is very special in the way that it can rearrange and the forms it can take on. All living things, including you and I, are made up of mostly carbon atoms. It's all a matter of how the atoms are arranged. If we were to rearrange coal atoms in a special way, you can transform that coal from a soft, burnable fuel that would not let light pass through it into the hardest substance known to mankind, a substance that is highly resistant to burning, a substance that captures a lady's eye, a substance that even lets light pass through it. You guessed it, the substance is diamond. How is it possible? How is it possible that carbon atoms could possibly be in sugar? Sugar. White crystalline sugar. If you look at the formula for sugar, C6H12O6, you'll notice the carbon atoms are represented. I'm telling you that these carbon atoms are in this sugar, and I'm going to prove it. By mixing sulfuric acid with this sugar, I can start a chemical reaction where the carbon atoms start to present themselves. Chemical reaction, it's exothermic, which means heat comes out. It's going to be hot, real hot, because sugar has lots of energy. It's the energy of the chemical bonds locking that sugar up with the hydrogen and oxygen. The water that will come out of this reaction won't come out in the liquid form, but in the form of steam. Carbon and its atoms are quickly presenting themselves, able to take up much more space than their original form because carbon's atoms themselves are actually mostly space. I don't know if you can hear it bubbling, but it is hot. Too hot to touch. Carbon is in sugar. Let's look at a different element, oxygen. Pretend for a minute that this is an atom of oxygen. Oxygen is an element, and an element because of its individual atoms, or building blocks. Oxygen is a gas that is flammable. In fact, oxygen helps things burn. The more oxygen a burning fire receives, the faster it will burn. As you know, if you can cut off a fire's supply of oxygen, the fire will go out. Let's go back to the atoms. Oxygen exists as a gas in its natural state. The atoms are free to move around. But here's the trick. Oxygen atoms only run around in pairs. All pure oxygen atoms are diatomic, which means they only move in pairs. Unlike carbon atoms can exist by themselves, individually. Oxygen atoms will not exist by themselves. They're always attached to each other. These diatomic molecules will not split apart unless they can combine with another atom of another element, like for instance, carbon. It is possible for an atom of oxygen to combine with an atom of carbon. This would make a molecule of the compound carbon monoxide. All carbon monoxide molecules look the same, but different from molecules of other compounds like carbon dioxide. All carbon dioxide molecules look alike and have 2 atoms of oxygen for every atom of carbon. Despite the oxygen present, carbon dioxide molecules do not burn. They deny the fire access to the oxygen locked in their molecules. The fire, despite being surrounded by tons of oxygen atoms, won't burn because it's literally smothered without the access to the oxygen, because those oxygen atoms are locked up with the carbon to make carbon dioxide, a substance that doesn't burn. Let's consider another substance, hydrogen. Hydrogen atoms, again, all look alike. Let's pretend for a second that this is hydrogen. Hydrogen exists as a gas, and the atoms of hydrogen, like oxygen, are flammable. Hydrogen is a flammable gas, and like oxygen, hydrogen atoms are also diatomic. That means that they only run around in pairs. The hydrogen atoms do not want to exist by themselves. They will always stay together. They will not split up unless they can combine with another element or an atom of another element, like oxygen. An atom of oxygen can combine with a couple atoms of hydrogen to make something you know as water, a common substance, H2O. Water can exist as a liquid where the molecules are free to move amongst each other, but then as a solid, water molecules are locked in place. With less heat energy, they take on a fixed position, a definite volume and a definite shape. The arrangement of these molecules, the building blocks that make it water, give it a lot of options for the shape or form that it might exist in. It is all about the building blocks and how they are arranged. But if you change the building block, you change the substance. If you change the molecule by so much as one atom, it's no longer the same molecule. It's a different building block for a different substance. Like for instance, with water, H2O, if you were to add an extra oxygen, you would have a different building block, H2O2. Because of the extra oxygen, you would now have hydrogen peroxide, H2O2, a substance that fish cannot live in and you cannot drink. Very different from water just because of one extra atom.